All right, in today's video, our goal is to create a window, and it's also to kind of cover how we could use the SDL callback system that's new with SDL3. If you're not familiar with what that is, that's okay. We'll talk about it a little bit when we get there. But first, I want to introduce everybody to the basic concept of the game loop and how we can implement that in a more traditional way. So here I've got a little file. All I've done is include the standard in.out.h header file that we often include in C. And I've got a main function. I've got this main.exe, but it doesn't do anything. I'll just delete it for now. So main.c, here we are. Let's go and let's get started. In order to make a window, there's a few little things we have to do first. There's some subsystems we have to initialize. We want to make sure we have a method of closing the window, which means we'll do a little bit of event handling. And then we'll also talk a little bit about organization as we go through this. Let's do the typical way you would create an SDL project not using the callback system. The first thing we would do is include our SDL3 SDL.h header. And I'll just also, while I'm here, include the stdio library. Next, we'll have our main function, which will have a couple of parameters we're going to throw in here, kind of your standard C parameters you have in your main function. If you don't know what these are, that's okay. We'll talk about these at a later date. And then we just return 0 for right now. And then this is our basic main function. Now let's talk about the parts we need. And this is kind of a across the board, most games function with this level of logic on the highest level of things. So we have, if I do this, we have our initialization. We have to initialize a bunch of stuff. So we'll initialize our subsystems. And a lot of stuff gets done in this particular portion. There's a lot of stuff to initialize. As your game grows and grows, you will initialize more and more. And we'll see that in action as we go through. Then we have to do some event handling. So we'll be handling input really more than anything. Then we will do something with that input. So we'll generally render at this stage. And then we'll quit after that. Now, the loop happens between these two portions of the program. You initialize your subsystems, and ideally, you are only initializing something once. You then go into your event handling. You take your input, you do stuff with that input, and then you render something to the screen. And you repeat those two steps over and over. Handle input, render to the screen. Handle input, render to the screen. So we could kind of say that this is our actual loop here. You can take this and just go ahead and move those over, tab them up. So this is our loop, and ideally, whenever you have finished what you need to do in your game, you have some method of event handling to quit your game, which will then call a quit function that ultimately is like destroying all the stuff we created. So if we created a window, we're destroying the window. If we're doing X, Y, Z, we're handling all of that in this final portion. Okay, so and usually what we do is we break this loop. And we'll see that in action now. So let's handle this one portion at a time. The first thing we're going to do is initialize our subsystem for SDL. And we can do that using the SDL_init function. And it takes a flag. And the flag that we're going to do, we're going to be working with video first. So we're going to actually initiate that. So SDL_init_video. And this function initializes that subsystem. So this is just an example of that. Now we can see here, if I hover over this, this is going to return a Boolean value. So it's either going to return true or false, and it returns true, I believe, returns true on success or false on failure. So whenever we initialize anything, generally speaking, it's good practice to make sure that you are you're checking to see that you initialize something correctly. And the way we can do that is by putting it in an if statement. And the statement just like this says, if this is true, then do this. But the truth is we don't want to enter this if statement, this conditional result. We don't want to get into this unless this is false. So we can do that, make sure that we're only checking if this is false initially by putting this bang symbol in front of it, this little exclamation mark. So this is saying if this is false, do this. And what we'll do here is SDL has this new feature or this new function to log, and it starts with a string literal. And so we can say here we were unable to initialize SDL underscore video. Okay. And then after that, we need a, so we're going to be handling a string here. And SDL has a function here, underscore log, which will go ahead and log, not log, get error, my bad. Get error. There we go. And then, of course, because we're failing to initialize, we will call SDL underscore quit, which is kind of like the designated quit function. You should initialize this function. You should call this function even if you have already shut down each initialized subsystem, and it's safe to do so. It is safe to call this function even in the case of errors in initialization. So this is a great time to call it. You can use this function with @exit to ensure that it is run whenever your application is shut down. Won't be doing that right now, but there we go. We have a method of quitting if this fails to initialize. Fantastic. So now we have the video system, the video subsystem up and running, potentially. The next thing we need to do is have a window and a renderer, which we use SDL to create. So if I do SDL underscore window, this is a data type. I can then create a pointer to a window, or pointer called window. And we can set that equal to a function which will return an address that will be stored within this window function, variable here, this pointer. And so we can use SDL underscore create window to do this. And this function takes in a pointer. This is going to be the title of our window. This is a string literal we'll put in here. So I'm going to say this is going to be our standard game loop. And for now, we'll just make the window 800 by 600. It's a pretty standard first window size. And then we pass in a bunch of parameters, and there's all kinds. If you go on the wiki, you can see what these are. I'm going to just make it resizable for right now. SDL window underscore resizable. There we go. Cool. So this is assigning a window. Or rather creating a pointer that's storing an address to a window, which SDL is doing a whole bunch of stuff behind the scenes. It's going to be doing a whole bunch of stuff with this window behind the scenes that you don't really have to do yourself. This is part of the luxury, the benefit of using something like SDL to create a window. There's a lot of code that's being generated and done behind the scenes that you don't have to worry about. Cool. So just because we made a window or we assigned this window doesn't mean that this function executed correctly. So we need to go ahead and make sure that window, this variable window, has something in it. It's not 0 or null. We want to make sure that it has it was done appropriately, and we can do so by checking. So we can say if not window. We can then do the same thing, SDL_log, unable to create window. And then we will %s. And by the way, this little like method of writing the log like this, I'm stealing this directly from the wiki. Some of the examples they had on there were written pretty much just like this. It's a very elegant, simple way of handling these kinds of errors. And then SDL_quit. Again, calling SDL_quit. Excuse me. Boom. So we've created a window, and now we're checking to see that it was initialized appropriately. Next thing we're going to do is we're going to create a renderer. So same thing where SDL has a type for a renderer. We're going to have a renderer written as so, and we have a function also to create a renderer. Excuse me, renderer. And here we're going to pass in our window, appropriately named window. And this next section is essentially deciding what rendering API you are going to be using. So you could type in like Vulkan or OpenGL. For now, we're going to leave it as null, but we have the power to change this later should we want to. And just like we did with the window, we're going to make sure that it's working. So if not renderer. So if the renderer is returned false, again, the only reason I'm doing this is because if there's nothing here, then we don't want to go any further. We shouldn't have to go any further in our program. Is false, then we can say SDL_log unable to create renderer. And I realized above I misspelt window. Wind now indeed. %s. Let's go ahead and SDL_get error, baby. And then call, of course, if we're here, we might as well call SDL_quit. And we can always handle like cleanup and stuff a little more adequately at a later date. This is simply just to get a window running and make sure it closes appropriately. Fantastic. So now we've initialized our subsystem. We have created a window, and we have created a renderer. That's kind of all the early steps we need right now just to get a window up and running. So next thing we have is our actual main loop. Let's go ahead and let's erase this for now. And let's create a variable, maybe a Boolean variable called running, and we'll set it equal to true just to initialize it. And now we can make our main loop. So while running, again, running is equal to true, we will first handle input, and then we will render in those two steps. First, we need to handle input. Now, we'll do more on input handling at a later date, but for now, we're just going to go ahead and do it the standard way. Again, found this on the wiki, and it's super simple to use. There we go. So while this poll event, we'll talk more about what's going on here. Oh, excuse me, I have to create the event, SDL_event. This is again a type event. Then what we're doing is we're polling for the event, and then in this while loop for this event, we are going to handle whatever various things should happen when we hit a button or when we click a mouse. For now, we're going to do the simple thing of assigning a method of actually quitting the program. And so what we'll do is say while, or excuse me, not while, we just created our while loop. We'll say if our event type is equal to SDL underscore event. I believe it's quit underscore quit. Yep, there it is. If the event type is equivalent to the SDL event quit enumeration that was created, and in this case, I guess it's number 256, user requests quit. What we want to do is leave this loop. We want to convert running to false. So we're going to say running is equal to false, which will exit us out of this loop. And then here we have our area of of this program where we will go ahead and destroy everything we've created. And as a general rule of thumb, if you create something in SDL, you should be destroying it. We will see that later when we work with SDL Surface. We work with the audio subsystem. There is all kinds of stuff with SDL. It's essentially creating stuff behind the scenes, and C is all about memory management. It's a big part of it. You want to make sure you're destroying things appropriately. SDL has dedicated destroy functions, by the way. SDL destroy will destroy the renderer before we destroy the window. We'll have underscore SDL underscore destroy window. Pass in the window. And then we will call, of course, SDL quit at the end, which I believe SDL quit is what's responsible for destroying or deinitializing subsystems. So that's the last thing we really want to call. Cool. So here we're handling a method of closing the window should we want to close it. Next thing we have to do is just render something, and we'll handle that really quickly. The first thing we have is SDL set render a draw color. Oh, excuse me. Set render draw color. This is the color that will be drawn every frame. It's like the background, essentially, you can think of it as. And we have to pass in our renderer as the first parameter. Then we have this uint r GB values, RGB, red, green, blue values. You can make all the colors you need with that. And then an alpha value, which serves as the level of transparency of this particular color. So if there were things being drawn behind this, if this value was anything less than 255, you would be making that thing visible. So we're going to do 255. Actually, we'll just do, I like a purple color, so we'll do 80, 0, and 80. It's a really nice purple. And then opaqueness, we'll have it full opaque. 255 is the highest value, which, by the way, 255 is the highest value for all of these. Next, we have to clear the renderer. So we'll do SDL render clear. Renderer. And then the last thing we need to do is call our SDLPresent, which is, I believe, the function that swaps the buffers. You can see that probably once I get here. This function clears the entire rendering target, ignoring the viewport, clip triangle. Note this is clearing also set fill pixels, yada, yada, yada. Make sure to invoke SDL appropriately. This draw color function, which we just did. Let's go ahead and pass in our renderer to this. And now, ideally, in theory, if we compile this and run it, we should have a window that's created. Let's go and let's do that. I don't know if I have, oh, I do. Okay, sick. Let's go and let's compile and see what it says here. Undefined reference to win main. Oh, I have to save first. Excuse me. Let's do that again. We compile. Let's run it. And it's not running. Why? Because I have once again forgotten to include my DLL file into into here. I will go ahead and pull that up real quick. If you don't know what I'm talking about right now, if this sounds like news to you, you have to include some DLL file. I would recommend you watch one of the earlier videos in the series where I show you how to link SDL appropriately. So I dropped in my DLL, my 64-bit DLL. Let's go ahead and let's try to recompile now that we might not need to recompile. We'll do it anyway. And now run. And there we go. We have our window. It's a beautiful purple. Very simplistic, nothing crazy going on. And because we handled this poll event here, we're polling for events. If I hit this escape or this close button, not escape the button, by the way. If I do that, nothing happens. I'm doing it right now. If we hit this, it should close. And it does. We're good to go. This is opening a window in the simplest way. And it's very little code, less than 50 lines of code. And we've got a window up and running. If you try doing that with the Windows API, it's crazy. It takes forever. This is a very fast way of doing it. So this is the traditional method. Now you can abstract this out however you want. You can take all of your input and put it in a different function. You could set up your own kind of callback system using function pointers. We're going to next do the callback system that is included in SDL3. They basically have a new way of interfacing with the API or excuse me, with the library to just kind of clean up the code a little bit and organize your code a little differently on the highest level. Not much else changes in terms of how you write your code and what you're ultimately writing and where you write it. It just looks a little different in the file. So let's go and let's make a new file. I'm going to call this main_callbacks. And we're going to have we're going to compile a different function, or excuse me, a different program using this C file here. So to do this, the first thing you need to do if you intend to use the SDL callback system is you have to define SDL_main_use_callbacks. And you have to set that equal to 1. You're never going to deal with this again in the future. This is just something that you need to do in order to tell SDL, hey, I want to use the callback system. Next, we will include our SDL.h file, excuse me. And then we will also include our SDL3. Oh, excuse me. I didn't even realize I missed the 3 up here. SDL, I like my auto completion. SDL3/SDL.h. And it's not SDL.h here, SDL_main.h. Cool. Now, the big difference is that you won't have a main function like you do here. The main function is being created behind the scenes. You do not have direct access to it, at least not in theory. It's hidden from you. Instead, we're taking those parts. Oh, excuse me. We're taking those parts of this file or this organized program here, and we're putting them in functions provided to us by SDL. So, for example, we had to initialize our subsystems at first. Well, we have an initialize function that SDL will provide to us. The next thing we did was handle input. We have an input handling function in SDL for the callback system. Same thing with rendering, or rather we're going to call it iterating, which is kind of like the loop itself. And then quitting. We have a quit function as well. And we'll see what that looks like now. Now, the type we're going to have is SDL_AppResult, which returns one of 3 things. You'll either have an app success, app failure, or app continue. Now, app continue is what we want to do to go to the next stage, right? So if we're initializing and everything goes right, we want to use app continue. If we intend to, if we have the intention of closing the program during the initialization stage, we want to use SDL app success. And then if something goes wrong, we'll use SDL app failure to ultimately leave the program and close it. So we're going to start here with SDL app result. And excuse me, that's not the function itself. This is the type. The function we're going to call is SDL_AppInit. And this takes a few things. We have a void double pointer to app state. This is something you'll find on the wiki and the examples as well. And then everything else we would expect from in a C program, we're going to have int argc and char star argv, and it's an array. And then everything that would go in this would be our initialized, everything we need to initialize, our subsystems, any other systems. You know, if you're not just working with SDL, oftentimes other libraries have their own initialization functions to get things going behind the scenes. This is where you would handle that. So let's go and let's write this out. The first thing is, if we're going to continue, if we know we've written this and we want to keep going, we're going to return SDL_app. This is all caps, continue. Cool. Let's initialize our subsystems. Actually, before we do that, let's just get the rest of this going so we can see this entire new format of working with this. Next thing we have after our initialize is going to be app result. Again, this is the type of the function. The next thing we need is SDL_AppEvent. And then into here, we are passing in, I believe it is also app state, app state. And I don't think we need anything else off the top of my head. Let me remember real quick. Oh, of course, we have to create an SDL event pointer. SDL event pointer event. Cool. If everything goes right here, again, we return SDL_app_continue, all caps like that. After that, we have SDL_AppIterate, and we have to put the type first, SDL_AppResult. We will then have SDL_AppIterate. And into this, we pass in our app state. And again, just like before, return SDL_app_continue. Continue. There we go. And then just to recap real quick before we do the last function here. We're initializing. Oh, excuse me. Please go away. Go away. There we go. We initialize here. Then we handle event functions. Sometimes VS Code drives me crazy. We have our initialization function. We handle our events. This AppIterate is essentially our main loop. This is essentially the game loop. The idea being that the callback system is calling whenever these events happen to appropriately handle it during the loop. So all the event handling will be written in that. Oh man, that's annoying. Please go away. Okay. All of this stuff, event handling gets done here. And then this is where all of the logic for the game loop will go. Last thing we need is to quit. Now we don't actually need to, it's not going to be an SDL app result type if we were ending our program. Instead, it's just going to be a void function that's called, and it's referred to as SDL_AppQuit. This is different than what we used in the other function, by the way, or the other program. Here we had SDL quit, This is SDL AppQuit. This is exclusive to, there we go. This is exclusive to this callback system, which I believe SDL AppQuit calls SDL quit. Maybe if we hover over, it'll tell us. We should also be passing in our app state, by the way. So SDL AppQuit. We have our app state. Awesome. Now, this is all the parts here. Again, if I were to put them side by side real quick, let's go to the main.c here. Initialization, event handling, and then the main loop as a whole is kind of thrown in here in this AppIterate, and then our quit would be done here. All of our cleanup would be done in this section, and that's the gist of it. That's the idea. Whoa, whoa, too many windows. Let's go ahead and close that. All right. Now let's actually go ahead, go through and make the window. We will create everything we need. And we're essentially going to create the same program, but using this callback system. So the first thing I would recommend doing is not having a bunch of globals. You could do this SDL underscore window and then have a window here. But I don't recommend doing that. And the main reason is, as a general rule of thumb, globals aren't very good. They're not safe. I would not recommend organizing your stuff in terms with using globals. If you do, you probably want to use the keyword static in a file to make sure that everything's encapsulated within that file. What we can do is in our initialize function, we can actually go ahead and create our kind of like a struct that holds our window here. The first thing we should do probably is initialize our subsystem, just like we did before. So I'm going to go SDL underscore init, and then SDL underscore init underscore video. Cool. Just like before, we want to make sure that this is done successfully. So we are going to put it in an if statement, put the bang in front of it. So if it returns false, we know. And then here we will do what we did before. Come on, Visual Studio, please stop doing this. I would like to see what I'm working on. Thank you. Okay, jeez. Oh, man. Just so you guys know, I don't really use like Copilot and stuff like that. For some reason, it was turned on one day when I opened up Visual Studio, and oh my gosh, Copilot autocomplete is the most aggravating thing I've ever had to deal with. It just wants to complete all your code, and half the time it's wrong. Oh, it's frustrating. Okay, I had to turn it off. That's why you don't see it now. Okay, we're going to SDL log again. We're going to have our string literal. We're going to say, this ain't working. SDL couldn't, or I'll just say could not initialize video subsystem. I probably wrote something else earlier. It's not the end of the world. I can always be more anal about it if I really want to be. And then here we're going to SDL underscore get error. Whoop. Cool. And now here, this is what's different from what we were doing before. Before we called SDL quit. In this situation, we actually want to return SDL underscore app underscore failure. And when we call app failure, it's actually going to go ahead and call SDL app quit. So we don't actually have to call quit ourselves here. It would be done here. And anything that needs to get done within this quit function will be handled at that time. Cool. So we have our subsystem up and running. Now we need to create our window and so forth. Now, the first thing, again, avoiding globals. This is something we don't want to do. We could have our various app state related stuff, like if the app should be running and all this other stuff. We can have that written within this AppInit function. And then we can use the static keyword to make sure that the lifetime of these variables are the lifespan of the program. So, and basically, they would live indefinitely until we close the program. Some people will also put this on the heap, and maybe we'll explore that at a different day. But the first thing I want to do is create a type definition for a struct called appState. And it will have a few different parameters or a few different members. It will have a SDL window and a pointer called window. It will have an SDL underscore renderer with a pointer called renderer. And then we'll have an alias for it just called appState also. Now, one thing that might be a little confusing compared to what we wrote before. Here we had these this window and renderer, and the scope of these are basically all throughout the main function here. You can access this renderer or window at any point. That's why we were able to just so easily pass in window and renderer appropriately. We're passing in these pointers. In the callback system, we are provided this void appState here. And what this is functioning as is kind of like a pointer that we pass throughout every portion of our program into the event handling, into the iterate function, and even into our AppQuit, which is how we can access this information at any point. Now, we could technically do that by creating a global variable, but that's kind of bad practice, generally speaking. So what we're going to do is have a pointer that we will assign to this pointer. So it's again, this is a double pointer. So we need to assign this to a pointer itself. And we can do that by creating our appState actual like struct within the initialize function, within the SDL underscore AppInit function. So I'm going to go ahead and do an appState type. I'm going to call it AS for now. It stands for appState. And I can initialize that to 0 by doing this. So we have created an appState. This is the appState that we will be accessing indefinitely. I can then do the whole thing I needed to do before with creating a window and creating the renderer. So I can go ahead and say as.window is equal to SDL underscore create window. Pass in our title. This is going to be our callbacks. I'll just call it that for now. That's fine. We had, I think it was 800 by 600 is what we did before. And then for the flags, we'll do the same thing. SDL underscore window underscore resizable. And there's all kinds of handy ones, handy flags that we'll use later. Oh, excuse me. Don't intend to do that. And just like before, we are going to check to make sure that this was done appropriately. We can say if not as.window. We can say SDL underscore, or excuse me, SDL log. And we'll say window could not be created, %s. And then we will SDL underscore get error. Let's see here, expected. Did I miss something? I did. Excuse me. Never, don't forget your semicolons, people. Awesome. So here we are creating our window, or rather we're returning a pointer to the window that is being handled by SDL, and we're assigning the address of that pointer. It's being held within this pointer here, right? Or the address of this window is being assigned to this pointer. We're checking to see that it was initialized appropriately. Then we do the same thing with the renderer. Is equal to SDL underscore create renderer. The first thing is we have to pass in our window, which is easy, as.window. And then again, just like before, this is where we could have, we could declare what type of API we want to work with. For now, we'll just say null. I think it defaults to OpenGL off the top of my head. I'm not entirely sure. We could always check that later if we really wanted to. And we'll do the same thing. If as.render, then SDL log. Renderer could not be created. We'll do our little %s and then SDL underscore get error. Awesome. I realized something that's really important. We did this earlier. If you need to end your program because something failed, you need to return SDL app failure. So we're going to do that here. Return SDL underscore app underscore failure. We'll do the same thing. Just copy that real quick. Put it right here. Cool. The last step we need to do is create a pointer where, we need to assign the pointer that is this pointer to our app state to make sure that this is accessible later. So this is really the variable, the pointer that we will be using to access this information later. So again, come here, I can say app state is equal to the address of AS, or our app state that's here. And I spelled app state wrong. There we go. And one thing before we keep going, and this is important, it's to understand the lifetime of a variable. This app state exists so long as we are within this AppInit function. However, we're not going to be calling this function again. So we will lose access to this app state, or rather, it will be kind of deinitialized to us. We need to use a keyword called static to be able to access this later. Now, this is going to live on the heap. Again, some people would prefer to put this on, or this is going to live on the stack, excuse me. Some people might prefer to have this live on the heap. And there's some benefits, drawbacks. It's the only time we're going to create this app state. So it's not necessarily the end of the world. It's also the only time we're accessing this function. Ideally, AppInit never gets called again. If you're worried about things like multi-threading, asynchronous stuff, then you probably want to put it on the heap. But again, we're only accessing this function once, and this data will be accessed throughout our function, throughout our program. It's not the end of the world if it's living on the stack. So I'm going to go ahead and leave it there. Cool. That is our initialization. We've initialized our window. We've initialized our renderer. And we've assigned our app state pointer to the address of our app state struct. Awesome. Next step is event handling. First thing we'll want to do, we have to do, of course, we have to do our, make sure that we can close our window. We have to check for that. So SDL type is equal to SDL underscore event underscore quit. Oh, excuse me. Just like that. Then we want to return, and unlike before, we're going to not return SDL app failure. We're going to return SDL underscore app underscore success. Success meaning we intended to close the program. And that's it. Unlike before, we didn't need a separate while loop for this. We didn't just need to say while, poll events, and all that. SDL is kind of handling that for us with this function. And then in the iterate, this is where we would put our rendering stuff. So Let's go ahead and let's do that. We need, oh, the first thing we need to do is have the ability to access our app state stuff. All right, our struct where we're storing our window and our renderer. Now, we can't just do this. We can't just say appstate.window. That doesn't work in this situation. We would have to typecast appstate because it is a void pointer. This is done intentionally. It allows a level of flexibility to how you organize your program. And instead of every single time we need to use appstate doing this, we go appstate pointer and essentially typecasting it like this every single time. What we're going to do is create another pointer within this function that will already be the type we need it to be. So we can do appstate. I'm going to call it AS again. I like working with AS. A little easy. And then app state pointer. This is our typecast for app state. So we're setting the address that is being stored here to we're setting this pointer to the same address that is being stored here, but in order to do so, we need to typecast it as app state. Cool. Now we can work with this. We can just work with our app state AS within our function. And I like to do this whenever I have to work with the app state. So we need to do the set the background color, set the draw color, set the clear, or call the clear function, and then call the present function. Let's go ahead and let's do that. SDL underscore set render draw color. And we're going to access that. Again, we have to use, if we're using a pointer to access a struct, we got to use this little arrow here. We're going to say renderer. And we'll do the purple again because I like that purple. It's pretty. 80, 80, 80, and 255 for that. SDL underscore render clear. AS renderer, passing in our renderer again. And then the last one is our RenderPresent. RenderPresent. AS render. Cool. Now I do believe SDL AppQuit actually handles destroying the renderer and the window and everything. But we can do that manually. Just like we did before, we could always do SDL underscore, or sorry, first we can do app state. Again, I like working with a new pointer. Makes life a little easier. App state pointer. App state, set that equal to app state. And now we can work with this. So the first thing we'll call is destroy the renderer, then the window, and we don't have to call SDL quit. SDL app quit's already going to do that for us. So SDL underscore destroy render, and we're going to pass in AS dash renderer. SDL underscore destroy window. SDL, or excuse me, AS dash window. Ooh, hold up. Trying to see things. I see an error. Trying to catch that. Oh, please go away. Thank you. Identifier render. Did I spell renderer wrong? Hold up. I think I spelled renderer wrong. Oh, I can't see. AS dash renderer. I'm assuming it's working. I can't tell. But that should be it. I don't think we need to call SDL app quit. We could do it anyway, like that. I'm going to not. I believe SDL app quit does it for us. And that should be it. That should be everything. Let's go ahead and let's see if it worked. We're going to save. We're going to go to recompile, but we got to make sure we compile the right thing this time. We're going to go here. We're going to type in underscore callbacks. And then we will name it main underscore callbacks. We have a problem with our quit function. Let's see. Void SDL AppQuit. Oh, excuse me. We have to pass in or declare app result here. Result. That's why. Save that. Recompile. It works. And now let's run that. Call underscore callbacks. I can't see the underscore. There we go. And this is our callback window. I can close this. And again, I can run our main one. And these are essentially the same program. They're two of the same thing. One of them is just using the callback system. One is using the kind of more traditional method that you would see. There's minor benefits to using a callback system. If you're writing for mobile, I believe that it is a necessity to use a callback system. At the end of the day, it's just preference, especially if you're writing something for PC, Windows, Linux, Mac. It's not as big of it's not as that important. For the purposes of this series, I will be using the callback system, mainly because I'm challenging myself to use it. I wanted to give it a shot. And also I think it'd be a good opportunity to try out some of the new features built into SDL. Anyway, that's it. We've got the SDL callback system up and running. And if you prefer to do it the other way, you can still follow along using the traditional method. I hope this has been helpful. See you in the next one.